Good afternoon. This is Charles Hanscat with the American Shotcrete Association, current president of ASA, and presenting a talk today on Introduction to Shotcrete. I hope everybody can hear me and can see the slides we'll be going through today. If there are any difficulties, I think in email there's the ability to contact the operator and get some of those resolved. I want to thank ASCC for inviting me to make a presentation today about Shotcrete. Been involved in Shotcrete since about 1977 and actually was out in the field as a gunman and shooting Shotcrete as a nozzleman and finishing Shotcrete. So have some practical experience as well as design experience in a variety of different structures. And I am currently, I don't know if this is good or bad, but president of American Shotcrete Association, and so representing them here today. We will have questions and answers. This is kind of an unusual format. I've done one other webinar, but not quite the same presentation style, and we can't do questions as the presentation is going along. So as I'm going along, if you have some questions, please write them down, and then you can ask them at the end of the session. We'll have a question and answer session. The presentation is copyrighted materials from ASA, so can't be distributed. My understanding is ASCC is recording the webinar and will be available for members to view, but it can't be subsequently recorded and distributed outside of the ASCC viewing. Just a little background on the American Shotcrete Association. Our vision is to raise the visibility of Shotcrete and to make Shotcrete as a process be understood and how it can be used in applications, a wide variety of applications. And as a trade association, we encourage and promote the safe use and the safe and beneficial use of the process. Today I'm going to cover a definition of Shotcrete, the two different Shotcrete processes that we have, environmental conditions that are important when you're shotcreting work, surface preparation, that's key for good quality repair, reinforcement details that may be a little different in Shotcrete versus cast-in-place concrete. We'll talk about mixed components, quality assurance, the application procedure, finishing and curing, and then talk a little bit about the ACI Nozzleman Certification, which is a certification that has been established by ACI, and the American Shotcrete Association, ASA, conducts ACI Nozzleman certifications around North America. We've worked certainly many in the United States and Canada, as well as some overseas in Singapore, Mexico, and increasing our usage internationally. So what is Shotcrete? And looking at the definition in ACI's concrete terminology, it's a method of placing concrete with high velocity to achieve compaction. And the key here is the high velocity. We're not just sputtering out the nozzle with low velocity where it just like a plaster gun hits the wall. It comes out very, very high velocity. As the material hits the wall, it compacts the material in place. And that's where we get consolidation and compaction, unlike cast-in-place where you have to use a vibrator generally to get the adequate consolidation of concrete. So Shotcrete, it's not a product. It's not necessarily different than concrete. It's just really a method for placing concrete. We have a wide variety of uses. Because Shotcrete is naturally kind of a free-form type of application, we have seen extensive use of Shotcrete in underground applications. It's used in slope stabilizations. If you drive along a lot of the interstate highways, you'll see where they've used some soil nails and shotcrete to hold the slopes in place. Shoring that may be temporary or permanent shoring of construction, underground construction, basement type construction. A lot of use in infrastructure rehabilitation that can include bridges, dams, buildings, historic buildings. And we're going to go into details on more of these particular uses so you get a good feel for how shotcrete could be used potentially in maybe some of your projects. We'll also talk about new construction and then architectural shotcrete. Of course, architects get involved in liking a lot of different shapes, and shotcrete has some natural advantages in providing concrete in place that's got various shapes to it. So in underground, I'm not going to go into great detail. I don't think there's a whole lot of ASCC members that do underground mining work and tunnel work. But just so you're aware of the full spread of applications, certainly in mines we have ground support, haulage ways, shaft linings, construction of ventilation walls and barriers. Shotcrete's probably one of the most used concretes in underground work is concrete that's applied with the shotcrete method. And here's a picture of a tunnel. When I shot shotcrete, I could actually do a little bit smoother than that. It's a little bit rough. It was one of the few pictures we had where we had a lot of light, where we could show how the shotcrete was used in the roof of the tunnel, roof and walls of the tunnel here. But because tunnels typically are not rectangular, they're not conducive to getting a form in and casting in place concrete, shotcrete has a natural advantage here. Also, other underground applications, and where we're seeing actually quite a bit of use of shotcrete in the U.S. is in underground water storage chambers. There's floodwater storage here in Chicago. We have the Deep Storage Project, which is a lot of underground caverns that are being stabilized with shotcrete, and will store stormwater that happens to basically channel that stormwater, hold that stormwater so it doesn't run off into the Chicago River and Lake Michigan without and creating problems. Also, subway stations in New York City, the East Side Access is a huge project underway and has a lot of shotcrete on it, as well as many other subway stations being added to the New York system. Hydroelectric projects, haven't seen a lot recently, but there have been in the past powerhouses, surge shafts that are associated with dams that use shotcrete. Here you see a picture of a tunnel enlargement. Once again, an arch shape is very common in tunnels and underground. And the mechanism you see in the lower left-hand corner of the picture is actually a robotic arm that holds the shotcrete nozzle in place. The operator can stand back and operate the nozzle for placing shotcrete. It doesn't have to be directly underneath it where there may be issues in terms of fallout of shotcrete being placed. And you saw the tunnels that looked rather rough. Shotcrete is also used in aqueducts where it has to be finished and smooth for providing a fairly low friction surface for wastewater flow underground. And this is an example of an aqueduct. Here's some subway stations. These are overseas where they came in, basically blasted the rock, stabilized it with shotcrete, and painted it to look nice. We'll have some nice pictures from some of the new work going on in New York City once that's completed. Slope stabilization is another widely used application for shotcrete for rock slope stabilizations where the rock is not stable due to freezing and thawing. Water gets into joints of rock and may make it unstable. Earth embankments that may not be stable without some kind of soil nailing. Creek channelization, where we basically line creeks to keep the water flow from deteriorating the walls or sides of the creeks, channels, and containment beams. Here's an example. You can see a tunnel portal The shotcreters or the nozzleman's working out of a man lift here, and you can see on the upper left-hand corner of the slide the shotcrete being applied to the surface along with some soil nails. These are just anchors that go back into the soil, maybe back into rock, maybe just a long embedment in soil to hold the slope in place. In the picture in the lower right, you actually see the setup. There's an air compressor and a concrete truck that's being used to supply the concrete to the nozzleman that's at the upper part of that picture in the up at the top of the man lift. Here's a shotcrete application where they actually wanted to slow down the flow of the material along the creek, so they created a rock-like surface that would provide some natural resistance and friction to that water flow as it went down the channel. Shoring is very common. Soil nail walls. We talked about soil nails being used for ground support and slope stabilization, but it is common also in basement walls. Tunnel portals. These are the openings as you go into a tunnel. Underpinning of buildings. When you're in a large city where you come in with basement walls that are adjacent to another large building, it's not unusual to underpin the adjacent building. And widening bridge abutments and foundation lagging, which I'll show you a picture. Here's soil nail walls for buildings. You can see this is basically a basement that's constructed with the soil nails. They're the rectangular plates and then the anchors going through the plate back into the soil or rock to hold that wall in place. So that helps provide some structural stability to the wall with the soil nail. And shotcrete, you can see because it's a curved surface that shotcrete has some natural advantages there. Here's a very common one where we had piles that were driven. Lagging was placed between the steel piles. And then rather than forming and casting that wall, it was already basically formed by the steel pile and the lagging, so reinforcing was put up. You can see the large, called whalers, the horizontal beams with the anchors that go back into the soil. But shotcrete is basically being used to build the structural wall that's going to be the final wall of this basement. Soil nailed slope. This is similar to the picture you saw before, except it's a steeper slope adjacent to a railroad track. Shotcrete's good when you have limited access. You can get, basically, if you get access of a man in a man lift or off a scaffold, that's really all you need in terms of access to be placing your concrete in place. Infrastructure rehabilitation, repair and rehab is a big market for shotcrete. We do marine structures, dams, bridges have been very popular. Bridges have a lot of overhead work when you're working on the underside of a deck, as well as the vertical work for piers and columns. Shotcrete's also been used for hyperbolic cooling tower repairs. I think ICRI had a project that won an award a year or two ago that had extensive use of shotcrete for replacing deteriorated concrete and that had been in cast-in-place cooling towers. Bulk handling facilities could be like salt storage, those of us that are up in the north that have to tolerate the winter weather. And they use salt on the roads. They quite often have domes, dome-type facilities that store this salt over the winter, keep it dry, and shotcrete's been used quite a bit for that. Certainly repair of chimneys. There's refractory that's used in the steel industry. And then this says heritage buildings, but historic buildings have seen quite an increase in use of shotcrete, and I'll explain that a little bit later when we get to a picture. Shotcrete, because it is easy to apply to an unusual shape, on this particular picture, the inset on the lower right is actually a lighthouse that's out in the, I think it's in the Bay of Fundy up in Canada, where they have very high tides, and it was very impractical to come in and recast the foundation for the lighthouse. So the repair was done with shotcrete This used an accelerator, and I think it also used silica fume to be able to get a very quick set on the shotcrete, so it could be placed as the tide was low and rehabilitate that surface without any formwork. Basically, surface was prepared. When the tide was low, it was washed off and then shotcrete. And here's a shipping berth, docking facilities. You get a lot of aggressive damage to concrete from the fluctuation in the water. It can be salt content that gets in. The chlorides corrode the embedded reinforcing steel. Maybe the cast-in-place concrete wasn't as strong as it needed to be. So you can see working off a barge, setting up scaffold. As long as you have access to the face where you can prepare the surface and then shoot the shotcrete, you can create a nice smooth surface that's completed. You can see the inset of the completed surface on the lower right-hand side of the slide. Here's a bridge repair, originally cast in place. Defective concrete in this particular area and was taken out and then replaced with shotcrete. And also bridge reconstruction. This is an arch bridge. Once again, shotcrete being rather free-form type of material lends itself to doing things like domes and arches and curved shapes. And this particular bridge in the New York area was a prime candidate for use of shotcrete. And here you can see curved silos, fairly easy to cast originally with cast in place. But when you need to do a repair to put up a semicircular form and cast and get the concrete in there is difficult. Where with shotcrete, you basically can take out the defective concrete and replace it with good shotcrete in place. It's also has been used for strengthening. This is a strengthening actually where you came and wrapped a jacket around the silo to increase the strength, the tensile strength of the silo. Here's a building. It's not unusual in historic buildings to have something, a brick facade or basically a facade that is not got its structural integrity, or the building's being repurposed and will have seismic loads that the original design can't tolerate. So the architect, engineer comes in and needs to consider, well, how can I strengthen the building while still leaving the appearance? So what has happened on a number of structures is actually taking the structure away from behind the brick, putting up temporary shoring, bracing to hold that wall in place, and then placing shotcrete walls on the inside of this historic building. Shotcrete, once again, you're only applying it from one side, makes it very easy to build out a structural section that can then be used to support the relatively low-strength brick or just old facade that may be in the existing building. We've also seen, this says seismic retrofit of dams, but in the West Coast, we've seen a lot of seismic retrofit adding shear walls inside existing buildings. With shotcrete, you can come in and basically close off a small section, shoot a wall, and add the structural strength. Shear walls, this is a dam, columns on bridges, wrapping it in a jacket to strengthen columns for seismic resistance. And another structures that may be in place that can't tolerate very high seismic loads, where you could come in and strengthen it with shotcrete. It's kind of a structural wall back behind the facade. And shotcrete has a lot of uses in new construction. We certainly do a lot of swimming pools. As a member of American Shotcrete Association, I'd have to say that swimming pools is probably, the number of contractors that do swimming pools is probably one of the largest segments of the marketplace. They tend to be small contractors that may have one or two rigs and do a lot of swimming pools. Swimming pools are free form. Typically you have curved sections of the transition between the wall and floor. A lot of water features now have a wide variety of different shapes. It's pretty unusual to see just a straight rectangular swimming pool anymore. Most of them have certainly free-form curvatures, as well as many with carved rock that have waterfalls when you get very high-end, certainly in commercial pools, as well as some upscale residences. Canals and water retaining structures. We showed the canal linings before, but certainly that's a potential for canals that are being constructed for new construction. Prestressed water tanks, prestressed concrete water tanks use quite a bit of shotcrete, either in the actual wall construction or the protection of the prestressing. And then domes and shell structures. We mentioned before bulk storage, housing buildings, and some military structures. I was working on a blast pond facility with the Navy where they had used shotcrete, 60 years ago, and has held up pretty well for their blast pond, where they basically detonated bombs to get a feel for what the pressure waves would be on the structures. And they could put boats or various things into the pond and test them for the blast capacity. Here's a big commercial swimming pool. You can see once again, we have curved transition between the walls and the floors, step facilities, a lot of intricate shapes that would be difficult to cast, but in terms of shotcrete, when you just shoot it in place from one side and then finish it, makes it quite easy for producing that shape. Here's a canal lining, a fairly thick canal coming into a transition into a large pipe, but it shows that we can do relatively thick sections. Canal linings aren't just necessarily a thin lining. It might be a structural section that's designed to take quite a bit of flow and long-term durability. Here's a shot of prestressed concrete tanks. These tanks can range in size up to over 300 feet in diameter, up to 70 feet tall, and many of them are constructed, the walls entirely as shotcrete. Some just use shotcrete for protection of the pre-stressing wire. Material storage domes has been an application here. It's actually an inflatable form where the form is raised. It's a plastic type form. It's raised with air pressure. A foam is shot in place on the underside to provide insulation and a little bit of structural strength to that form, and then shotcrete layers are applied and thin layers on the bottom for the actual structural integrity of the dome to carry the loads, not only of the superimposed loads from wind and snow, but also internal loads where solids are being pushed up against the walls. And here's a bobsled run. This is up in the Vancouver Olympics, and very tight tolerances for the bobsled runs, luge runs, and curved shapes lend themselves ideally to a shotcrete type application. On the insert in the lower right, you can see they actually did this during winter, so it had heating and protection from the elements when they were building the bobsled run. This has been a fairly new thing that's been popular, skate park facilities. A lot of municipalities, to keep the skateboarders off their park rails and places where skateboarders tend to tear up things that aren't designed to be skateboarded on, they'll build a skate park and allow the skateboarders to have a place to go and do their skateboarding. And you can see the construction photograph. Basically, there's no form. They're shooting it on the soil. They have templates there. You can see a plywood template that provides the shape, the final shape that they're looking for, and the minimal amount of reinforcement. And then on the lower right, you see the inside of the completed skate park facility. And we've seen actually a move in what I would call more traditional cast-in-place wall and building type construction. This is where you may have a structural wall, 8 inches, 12 inches, even 24 inches thick with 2 mats of steel. They can actually be shot with shotcrete pretty effectively. The advantage here is you don't have a structural form that has to have a lot of ties and a lot of strength to carry concrete loads as you're casting up the wall. There's basically one-sided form. It can be a relatively light form because it doesn't need to have the ties and the strength, and you don't have stiff backs and whalers that are needed to hold the form together as you're pouring concrete inside. You just have the pressure of the concrete being applied with high velocity onto the surface. And architectural, we've certainly seen rockscapes and zoos. There's been some sculptures, ponds and waterfalls, a lot of times associated with high-end swimming pools. And this is, in many ways, I consider almost an art form. We have people that will come in and take the shotcrete and actually make it look like rock. They'll add color. They'll add you can see in this picture of a zoo that they simulated a basalt rock, and they've actually added the lichen color, the green, like it's aged. And you can come in and if you didn't know it was shotcrete, suspect that would be a rock, an existing rock face there. Trees, Disney has used, I think, shotcrete for construction of some of their trees. There have been other zoos that have used concrete for an indoor tree type exhibit or for access for the monkeys and all to climb up on. They don't have to worry about the tree dying on them. And actual sculpture. You can see here this line was, this is also up in British Columbia and was carved out of shotcrete. So you have the durability of concrete, but the art form that will be very attractive. You can see in the picture in the lower right or on the right-hand side that this lion that you see inserted on the left is actually on top of the pier there on the bridge. So that's an overview of the uses of shotcrete, history of shotcrete. We actually were over 100 years old. Carl Akeley made that first shotcrete gun up in the upper left-hand corner. That picture is a dual-chamber gun that was the same type of approach that we still can use in dry mix guns. We've made some evolution in technology, but this basic technology still is applicable. Carl Akeley was actually a taxidermist and was required, he had a large elephant, I believe, that he needed to come in and plaster, and he just, the handwork associated with the plastering was a lot of handwork, taking very laborious, and he came up with a gun to actually shoot it in place, and that was the evolution of dry mix. You can see in the 20s, dry mix being used for slope stabilization. Obviously, OSHA isn't quite in place yet. Guys working off ladders, standing up on top of rails, and no fall protection. But here, history of shotcrete in the 20s. You can see a gun, and this is actually, I think I can draw an arrow here. This is the gun. I put a red arrow. That dual-chamber gun, that same basic configuration can be purchased from Allentown, who manufactures this type of equipment still today, the same basic process. In fact, I was in a Nozzleman certification 2 weeks ago and went back into their shop, and they had a gun that looked exactly like that, and they had used it within the last couple of years. And we basically have the same thing today. We've evolved in terms of guns, dry mix. We also have wet mix. I'll go into the process. But we use basically a gun or a pump that puts the material into a hose. The hose then transports it to the nozzle where it's shot out at high velocity onto the surface. And this shows you an industrial application where shotcrete is being used to build a wall in place. A lot of people ask, well, how is shotcrete different than gunite? Well, gunite was the old trade name established by the Cement Gun Company for dry mix shotcrete. And When the American Railway Engineering Association and ACI got around to writing documents about shotcrete, about gunite, they couldn't use it as a trade name, so they adopted the term shotcrete. And we have ACI 506 that was started in the 50s that is producing documents, specification, guide to shotcrete, guide to underground shotcrete, fiber shotcrete. All those documents come out of ACI 506. In the 70s, we started with steel fiber. I'll talk a little bit about silica fume. And in 1998, we formed the American Shotcrete Association to help increase the visibility of shotcrete and the adoption of shotcrete in a variety of different applications. In 2001 was when the Nozzleman Certification program was established, and we have well over 1,000 certified nozzlemen now around the country, ACI certified nozzlemen. There's two basic processes, dry mix and wet mix. Dry mix, you can see the photo or the picture in the left-hand side. That's a small rotary gun. These were introduced in the 50s versus that dual chamber gun like Akeley introduced in the early 1900s. But in a dry mix process, we basically take the material, put it into a gun. The gun then takes air pressure and pushes that material through the hose. At the end, the nozzle is attached to a water line. Water is physically injected into the stream. That's where we hydrate the material and then shoot it in place. So air velocity carries the material all the way through the hose and then adds that velocity as it comes out the nozzle. This is just a cross-section. I won't go into great detail, but it shows you that in the nozzle, we basically the material comes from the right-hand side. Water's injected where you see a nozzle body, water ring we call it, that injects water at high pressure into that material stream of dry sand and cement, sometimes a small coarse aggregate. It goes through the nozzle. It is accelerated by the Venturi effect and mixes. You can see some of the steps that kind of make a rough area inside the nozzle that help to have turbulence that help mix the freshly introduced water to the dry sand and cement or coarse aggregate. And this is a typical setup. You can see this one is actually using a large super sack, we call it. These can range up to 3,000 pounds of pre-bagged material that's put into a pre-dampener. This is basically a chamber that adds a little bit of moisture so it's not super dry when it goes into the gun. That cuts down on some of the problems with static and buildup that we get on shooting dry mix. It's then dropped into that conical funnel that you see on the kind of the bottom left of the slide. And then the gun facility there actually takes from that hopper in through the gun and shoots it with air pressure into the hose. Wet mix is the other process. This is the most prominent now. We probably have I see about 25% of the work is done in dry mix, 75% is wet mix. Wet mix takes a concrete pump, a small concrete pump, and then pumps prehydrated, it's already mixed concrete, in through the hose. And then at the nozzle, we introduce air. The air pressure then is what conveys that concrete pump material at a high velocity out of the nozzle into the receiving surface. So the key here is the material is not dry, it's already wet. It's often delivered in a concrete truck to the pump where it's then pushed with hydraulic cylinders. The swing tube type hydraulic pumps are the most common in wet mix. And then if you've ever seen a concrete pump in operation, you know you're not getting high velocity out the end of the hose. And that's why we have to introduce the air to help give it velocity. So the wet mix nozzle is similar to the dry mix. Basically here we have hydrated concrete coming from the right-hand side to the left, comes through the hose into the nozzle. We inject air, and then air helps, that air pushes it through the nozzle and exits out at a high velocity. We can also add accelerators. A lot of times in tunnel work where you want to shoot it and have it set very quickly, or that, for instance, that lighthouse project I showed you, where we want to set before the tide came up, you can use accelerator and wet mix. And there's special ports that are put in to inject that material into the flow. Typical wet mix is delivered in a ready mix truck. It's the same concrete that we can order for cast in place. The biggest difference is we tend to go with a smaller coarse aggregate, maybe a 3/8 to ½ inch maximum size for the concrete. And a lot of times the owner will say, well, or an engineer will ask, should I specify dry mix or wet mix? And it's really dependent on the experience of the contractor and the type of project. If I'm on a repair job that has a lot of stop and start, dry mix is good because I haven't hydrated it. The water's not introduced to the mix until it exits the nozzle. So we can stop at any point without having a lot of material stuck in the hose that you have to get rid of. If you had wet mix at that point, you stop, you'd have to clean out your hose every time that you stopped and then restarted. So it really depends on the process, on the application. If I was shooting a 2-foot thick shear wall, heavy reinforcing, I'd certainly be tending to use wet mix because you can get higher production. You probably get about 4 times the production in terms of cubic yards per hour with wet mix versus dry mix. So dry mix is good for smaller areas, good thin repair areas, where wet mix just generally would be better for thicker sections that would require a higher production rate. Environmental conditions that affect shotcrete, because we're shooting basically we're building our sections from one side out, and that outside surface is always exposed. We need to be a little bit more sensitive to exposure to cold weather, hot weather, wind, rain. We don't have the luxury that you would have on a cast-in-place wall where you have it formed. You can just put a tarp over the top if it rains, and it's not going to really affect your section. Where in shotcrete, we have one entire surface is generally exposed because that's the side that we've applied the shotcrete from. Our rule of thumb is if the air temperature is 40 degrees and falling, you stop shotcreting, because shotcrete tends to have more cement than cast-in-place concrete. We find that we can reach that 500 psi level in shotcrete fairly easily if it's 40 degrees and going towards freezing, that it'll reach the 500 psi pretty easily without freezing. If it is extreme conditions, you can certainly use warm mixed water. As with concrete, you don't put shotcrete on frozen surfaces, and as with concrete, you try to keep your mixed temperatures above 50 degrees. Hot weather, it's similar to concrete. Once again, we have that exposed surface. So if it's 100 degrees or over, you have to have some special provisions with shotcrete. It may be fogging to help cool the surface to try to control early age plastic shrinkage cracking. We also like to keep the mix as cool as possible, so you may have cool water. If you're doing dry mix, you may have a tank where you can actually cool the water before it's introduced into the mix. If it's concrete delivered for wet mix, you can use the same hot weather provisions that you do for normal casting of concrete. Also in shotcrete, it's not unusual to put up sunshades to keep the area that's being shot shaded, so you're not building up the solar radiation gain of heat. And also then to fog or mist the surface to help cool it and to control that early age plastic shrinkage cracking by keeping the surface from evaporating quickly. Wind, if you have a very windy location where the wind is coming across your surface that you're shooting against, it can tend to separate the nozzle stream. You can get in closer and help prevent that, but when you reach a certain point with high winds, you just can't shoot unless you put up a barrier to basically block the wind. And you can also use different nozzles to help concentrate the stream, the material flow, so that you could basically concentrate it to help to counteract that wind trying to separate your nozzle stream. But that's something that really, it's dependent on the job, on the exposure, the amount of wind that you have, whether you're doing wet mix or dry mix. These things all kind of come into play with taking consideration of wind. And also because we have the surface exposed, if it's very windy, it does lend itself to early age plastic shrinkage cracking, where you may need to consider fogging again, or some kind of protection to keep the wind off the surface, which would not be that much different than if you're casting a large floor that's exposed to windy or dry conditions or hot conditions. Rain, you don't apply shotcrete in the rain unless it's covered, like the picture in the inset on the right. You can certainly cover and shoot at any point. You also don't shoot concrete into ponded water. It's just like concrete. You don't want to put it into a really wet situation where you're going to tend to water down the concrete, the cement paste, and reduce its strength. Shotcrete does tend to have some benefit because of high cement content. We also use microsilica in a lot of shotcretes. Microsilica or silica fume is same material, different term. Helps to resist washout if you do get a rain. In repair, we like to certainly have saw-cut corners so that you have a square corner. We don't like feather edging. We'd like to have an inch clear behind rebar so that we actually kind of lock that patch in place. And certainly your repaired section is not going to be competent if it's not shot on sound concrete. The concrete surface needs to be sound. Otherwise, if you have a deteriorated concrete you're shooting good shotcrete on, the good shotcrete can fall off because it's not going to bond because the poor concrete hits the substrate. So surface preparation is certainly key to good repairs. And we also like to bring the surfaces up to saturated surface dry. So there's a little bit of moisture. It's not dry, very dry, that it tends to suck the water out of the cement paste as it hits that surface. We do not recommend bonding agents. If you're casting concrete against a concrete substrate, a bonding agent can be effective. With shotcrete, we actually have an abrasive, almost a sandblasting in place. The high velocity of the sand and cement and coarse aggregate actually kind of sandblasts the surface, opens it up, and encourages a very good bond of shotcrete, of the fresh shotcrete paste to the concrete substrate. If you have a bonding agent, a lot of times it can actually tend to be sandblasted off by the shotcrete. And we've also run into problems where if you're not in the open window time of that bonding agent, it can act as a bond breaker rather than a bond enhancer. I mentioned before, we typically use one-sided forms. The form needs to be stable, so if you're shooting against it, it's not going to vibrate and create issues with cracking of the fresh shotcrete before it's set. You can use form release agents just like in cast-in-place work to allow stripping of the formwork. There are many applications where the formwork just stays in place. I showed you that basement wall where it was steel piles with lighting in between and it's basically shot in place and left there. Reinforcement needs to be stable. Just like in cast-in-place, you want to be able to embed that rebar, not have it be vibrating when you're placing shotcrete adjacent to that previously placed shotcrete section. We do use in shotcrete, if it's a thinner section, wire mesh are used. If you are using steel fibers, don't use wire mesh. There are problems with buildup with steel fibers on wire mesh. Alignment control, because it is kind of a free form, we use shooting wires. These are wires that are stretched to give us the actual shape that we're going to screed to, and they allow us to give a very good tolerance. You saw the bobsled run, various things. We can get very close tolerance on the thicknesses, cover thicknesses, and overall thicknesses of the sections. We use ground wires. There's pencil rods. Depth gauges you can actually probe through, and sometimes if you have a construction joint, a water stop joint, You may have formwork that actually gives you a good gauge for the thickness. So here, the picture on the left is a ground wire. It's up in the corner. It just shows you that's going to be the corner of this column or wall intersection. On the right is a pencil rod that's showing how it's going to have a free form kind of curvature to a column as it flares up. Cement, basically, we use the same as concrete. We're using the types 1 and 2, typically, rarely a 3. 3 is high early, and we don't generally need that because we have a lot of cement, and we typically use a silica fume or microsilica that adds strength. Water-cement ratios are low, 0.35 to 0.45. That shotcrete is in many ways self-limiting. If it's too high a water-cement ratio, it doesn't hang on an overhead section, and it tends to slough off more easily on a vertical section. So we'll find with dry mix, you typically range from a 0.35 to maybe 0.42. Wet mix may go as high as 0.45. If it's over that, it just is not able to be shot and stay in place. We do use silica fume. This is a very small particle. It improves the adhesion. You can see those pictures. You can see like a beehive shape, and it's not a great picture, but they've shot almost a foot of thickness of shotcrete in place in one layer. The silica fume increases the adhesion to substrates. It improves the cohesion. That's the ability of the material to stick together, and that improves then the buildup before you can slough off. It also tends, because it's stickier, tends to decrease rebound. That's the material that would tend to hit a substrate or a previously shot area and bounce off. That's what we call rebound. It also improves compressive strength, flexural strength, improves durability because we reduce porosity. That gives you better resistance to chemical, sulfate attack, chloride ion penetration. We also can use other SCMs, fly ash, which you typically see in your cast-in-place work. It has a lot of benefits. In the summer, it will slow down your set. In the winter, you may not want to use fly ash and shotcrete, especially if you're overhead or in vertical surfaces where you want to have that set up faster. It does make it easier to pump if you're in wet mix because the fly ash acts as little ball bearings, as small round particles. There's a couple different classes. So once again, it's good in hot weather, but maybe not so good in cold weather. It does reduce the permeability or porosity that increases durability. It has a little bit higher strength long-term, a little slower at 28 days, but it does build long-term. And it has some ASR resistance, which can be a benefit for shotcrete in areas that might have an ASR aggregate or prone aggregate. Slag is another SCM that I've seen being used more commonly, generally a grade 120, and has been used in shotcrete 30 to 50% of the cement replacement. It also has a little bit slower set time. It builds strength about the same as cement, but has a lower heat of hydration. Reduces permeability, that increases durability, and does have a little bit of ASR resistance, not as good as fly ash apparently. We do use set accelerators. Talked before how we use it in tunnels. It might be used in a highway where you just get it opened at night and you have an area closed off and then opened up for additional traffic early the next morning. So that's when you may use an accelerator in a bridge repair. We also do use hydration control. This allows the concrete and wet mix to go dormant so it doesn't hydrate, doesn't start to set up, and it can go as long as 72 hours. This has been used in tunnel works where they pump maybe a mile or 2 miles underground, as well as areas where delivery times can be affected. And it does not affect the long-term performance of the concrete. We can add air entraining. Certainly wet mix, you get your concrete delivered with air entraining. One thing with shotcrete, as it hits the surface, you will lose air entraining. So if you want to achieve say a 3 to 4%, you may in place air, you may actually be shooting an 8% material as delivered. Just to give you an idea of air entraining, here's 2 samples that were shot. And This is what it looks like when it didn't have air entraining. This is how it went through the cycles with air entraining. We use standard aggregates. I mentioned before, we tend to limit our coarse aggregate to no more than 3/8 inch. ACI 506 has a couple gradations, both a 1 and 2. 1 is a fine aggregate only. The 2 gradation is a 3/8. We do use fibers. Typically, microfiber is used for control of early age plastic shrinkage cracking. Then if you're looking for toughness and impact resistance, we do tend to go to steel fibers or longer macro synthetic fibers. Finishes, we can get any kind of finish that you can get to exposed concrete. The finish that you could provide on a floor or wall, we can typically do in Shotcrete. It ranges from the least expensive, the natural or gun finish, to the most expensive would be something that's carved, like this structure you see. So this picture, the top picture is the gun finish. You can see little pock marks from the aggregate hitting. The bottom, more expensive to have a carved face. This is a representation. We can do float finishes, a screed finish. Basically, you shoot it, you screed it, and it gives you a nice flat tolerance on your thickness. Here's a typical float finish, very similar to what you can get with a plaster wall. Sponge finish. And we can actually do hard trowel finishes. If it's an outdoor exposure, we tend to not recommend hard trowel just because of freeze-thaw resistance. But it is something that we can do if required by the architect. Curing, because we have an exposed surface, it's important to cure, especially in hot, dry conditions. And hydration, curing is the same that you have in cast-in-place concrete if you're casting a floor or a cast-in-place wall. Because of the exposure, we often will have fogging nozzles on the site where we can fog the surface, and then we cover it with a blanket, maybe a Berlin type material, burlap with plastic on the outside, and then soaker holes, as are shown here, that actually drip water down below the Berlin that's in place. But curing is important for Shotcrete as it is for cast-in-place concrete. If you can't do water curing, we do recommend the membrane cure, the spray-on cure. Because the surface tends to be a little rougher, typically application rates are about twice the manufacturer's quantity of volume that's used per square foot. Quality assurance, you need to be sure that if it is site batch that you get your weights, that there are volumetric mixers, but they need to be calibrated so you get the correct weights. But in Shotcrete, we have seen a move towards a lot of free bag mixes. Even some small wet mix applications, they'll get those big super sacks, mix it on site. So just adding water at the site and then pumping it with a concrete pump to make wet mix process. That has the advantage of basically control. You're not at the mercy of a concrete supplier in terms of their truck getting batched and then getting to your site. 506R is a guide to Shotcrete. It has a lot of discussion about application. We have a seminar we do, and the full day seminar that we provide to Nozzlemen before the certification sessions that goes into great detail in applications. And because we've reduced form work, we reduce equipment that's on the site. There's not the form work to eliminate after the job. We have a lot of sustainability advantages with Shotcrete. And that's true of new construction, rehabilitation, and repair. We do have ACI Nozzleman Certification. This is 5-year certification. They basically have to pass a written exam that is, with ASA required I mentioned before, the education session. They have to have 500 hours of documented shotcreting experience. And then they pass a 90-minute written exam. And then there's a performance exam where they actually shoot a panel that's 3.5 inches deep, 30 by 30, and shows different types of rebar. And they are graded. We basically core these and grade the cores on their ability to encase the rebar. And they can either pass or fail based on the cores. And as we wrap up, you need to use, when you talk about a certified nozzleman, that's only one part of the team. The certified nozzleman, he's the one that controls what goes in place. He's the kind of the final quality control. But you have to have an owner that's bought the proper equipment, that has maintained the equipment, that has all the crew members that are needed to do a safe, quality shotcrete job. And that's all the way from the owner's project manager through the pump operator or gunman, the hose draggers, the finishers. All these people work together to make the shotcrete team that assures that you get quality shotcrete in place. ACIcertification.org, that's an ACI, ACI Nozzleman Certification is just one of the certification programs of ACI. And our references, certainly ACI 506 has a variety, AASHTO. We do have a number of ASTMs that deal with shotcrete. I'm on the ASTM C9 committee that deals with shotcrete. We have also the International Tunneling Association and ASA. On our website, shotcrete.org, we have the archives of all of our old magazines, and you can search those archives and look for specific topics if you're looking for something about shotcrete or a particular project. And we do have a small staff, a half-time executive director, and then a full-time staff member that deals with the production of our magazine, as well as handling our ACI certification requirements. So I think we're ready for our question and answer.
Thank you. If you have a question, please press 0, then 1 on your touch-tone phone. If you wish to be removed from the queue, please press 0, then 2. If you're using speakerphone, you may need to pick up your handset first before pressing the numbers. So once again, if you have a question, please press 0, then 1 on your touch-tone phone. And we'll pause momentarily for questions. All right, I show no questions.
Okay. Very good. Thank you all for attending. And once again, the session will be posted on the ASCC site for review if you have somebody else that wants to go through it. And I'm also always available for questions if somebody wants to call.
All right, thank you. And thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect.